Hello, everybody. Welcome to the August edition of the Kubernetes Monitoring Helm Chart Office Hours. I'm Pete Wall, principal software engineer at Grafana Labs, and the primary engineer for the Kubernetes Monitoring Helm Chart. On today's agenda, we're going to talk about the version 3.3 that we released at the end of last week. What's in there, what sort of things that you might be interested in. We'll talk about some of the upcoming features. We do have some stuff planned for 3.4, which will actually be coming out maybe not next week, but probably the week after. So we're trying to get some of these new features out sooner and sooner. And as always, we'll leave time for questions and answers. K8s Monitoring Helm Chart version 3.3, what's involved? So we released this back August 15th. And this was really exciting for me because this one contained a lot of community contributed changes, and not just little small bug fixes here and there, although we do really appreciate those, but some notable larger changes as well. The first one that I know a lot of people have been looking for and was really excited to bring in is there's a new destinations map option. This one runs parallel to the destinations list. And the difference here is that the destinations map will load destinations using objects, right? So rather than an array of destination types, so this one can use objects. And if I can show this one here on the main README for the Helm chart, you can see how they are, how you can use this. So this is the current way, or the way that we've been doing destinations since 2.0. It's an array with name and type, and then all of the details for that destination. Destinations map sets the name as the key, and then everything else is inside of that key. This should hopefully make it really easier to incorporate this into tooling, especially like Terraform or Argo or things like that. Any types of place where you have you want to set your defaults and then you want to override for particular deployments one or two particular settings or something like that. Being able to reference the destinations by key, by name, using the key is going to be a lot simpler. You could do this before on this method, but you would be referencing it by index and just trusting that the ordering of those destinations is consistent across all your different deployments. This way makes it just a little bit more explicit about I am setting, a setting on this local Prometheus one. So this is pretty exciting. I'm kicking around. We'll see how popular this is and how people like it. I'm kicking around making this one a default, or even making the destinations type, this field here, be able to support either or. But I wanted to get this out there, and yeah, I'm really happy that we've got that. So give it a shot. Let me know how it goes. If there's rough edges, let me know. We can try to get that fixed. Oh dear. Okay. Just present. Y'all seeing the slide still? Give me a thumbs up. Okay, cool. Thank you. All right, the next thing that we've added, Helm hooks. So Helm hooks, within Helm charts, there is the idea of Helm hooks, which are tools that you can run before or after the installation or upgrade, or before or after the removal of the Helm chart. And they allow you to do essentially some kind of pre-setting of the environment, or finalization, cleanup of the environment after removal and something like that. We haven't had Helm hooks. I've been trying to not avoid them, but I'm trying to do things so that they weren't required. But there were two instances that came in that I felt like were worth investing the time to put into this. One of these was a community contributed change, and again, thank you for that. The first one, which is the one that came from the community, was what we do now is we delay the deployment of the Alloy instances until the Alloy operator itself is up and running. And so this makes sure that on install, the Alloy operator has had a successful running pod before we drop the Alloy instances. That just makes sure that there's enough time for things to kind of get up and running, and all the Alloy operator's leader election is underway and things like that before we put the actual Alloy custom resource instances onto the cluster so for the operator to resolve them into actually running Alloy instances. The reporter of this said that there was a race condition, and so this resolves that sort of thing. The other Helm hook that I added was a pre-delete hook, which kind of does the opposite, right? So before we remove the Alloy operator, when you're uninstalling the Helm chart, we're going to remove the Alloy instances first. So before the operator pods go down, before all of the resources like the RBAC rules that it uses to manage Alloy instances go away, we're going to remove, we'll use this pre-delete hook to remove the Alloy first. Let those go down, let them drain appropriately, and then we'll proceed with the rest of the uninstallation. This should hopefully fix some of the uninstallation problems that we've had since 3.0, where there were chances where if the Alloy operator was removed before the Alloy instances, then there could be some lingering artifacts left over. Hopefully this will address that. Another change in 3.3, the Prometheus scrape protocols is now something that you can set. This is something that you set on individual Prometheus scrape targets within the Helm chart. Some people wanted specific scrape protocols. This was something that we were able to change in, or you could set in the 1.something versions of the Helm chart, and we finally brought this feature up into the 3.3. And then the last, cron job metrics. We were added cron job metrics to the kubestate metrics scrape allow list. I call this one out too because this one lets me highlight that cron job monitoring has been added to Grafana Cloud's Kubernetes monitoring feature. So if you are pairing the Kubernetes monitoring Helm chart with Kubernetes monitoring within Grafana Cloud, you should be able to have visualizations of your cron job statistics too. So check that out. As always, the Kubernetes Monitoring Helm chart works great with open source versions of all of our databases. It's not required to be used with the Grafana Cloud, but we do obviously heavily work with them together. All right. Briefly, I want to talk about some of the upcoming features we've got planned. Like the disclaimer says here, this isn't commitment to working on these ones, but these are just kind of open sharing of the roadmap that we have. Some of these are coming sooner. Some of these are still, in the horizon, but these are the things that are top of mind for me that I'd really love to see coming in. The first one, this one actually bumped up to the top from a long time ago, but the front-end observability feature, a proper front-end observability feature. If users of the Helm chart from ages ago may have noticed that, or remembered that in like the 2.0 timeframe, we had a front-end observability feature, but that was removed. The reason for that is that feature actually was not compatible with the Grafana Cloud front-end observability, and I thought it just added too much confusion. And so before we really fully released 2.0, we removed that. Well, now we're finally bringing it back. And the reason why now and not earlier is because there are Alloy components that were added. I think it's like otelcall.exporter.faro and receiver.faro. That do the proper telemetry data handling to be compatible with the proper front-end observability feature. It should work just fine with open source Faro, but this is the one that you want to use if you are also using Grafana Cloud front-end observability. This one will include also a specialized Faro type destination. And so to properly pair this, you'll have a special destination called out just for Faro. But keep an eye out for this one. Log gathering and reorganization. This is something I've been talking about for a long time now. It's still in the works, but basically the idea that we'll be able to enable multiple paths for gathering pod logs. You'll be able to mix and match things like gathering logs from the file system as well as from the Kubernetes API, because sometimes you have clusters that have heterogeneous node types or different access policies or things like that. This should make it easy to work with those kinds of environments. Another one that I'm excited to take a look at, I need to do some more internal testing before I know all the ramifications of this, but Alloy soon will be able to deploy without cluster roles, only with namespace roles. This is a security requirement of some of the environments that I've worked with. And so I want to test the Kubernetes Monitoring Helm chart with Alloys deployed with no cluster roles. Alloy right now is the only component within the Kubernetes Monitoring Helm chart that still has to use cluster roles today. Everything else can be limited by namespace to just roles. But I want to make sure that all of the features work, or if there are features that only have to use cluster roles, I want to know which ones they are so I can highlight them. Finally, some new destination types are in the works. One of the ones that I'm planning for the 3.4 release, kind of on the same timeline as the Faro release, is some debugging destinations. So there's a standard out destination, but being able to pair that with some of the other ones should hopefully make it simpler to find the just get a quick snapshot of the logs without having to first store them into like a logs database and then read it there. It should be just easier to get a snapshot of things. And then the last one is cloud provider label enrichment. The idea here is if we detect that you're on a certain cloud platform, can we use that to add labels, add attributes based on the what we know about the cloud provider? So things like region or node labels, things like that, tags. All right, that is that's the end of the upcoming features, or at least the planned upcoming features. And so now it's time for Q&A. And Carl, I saw that you dropped one into the chat. Do you want to just ask that one? Otherwise, it's gonna be some silence while I.
Oh yeah, that's all right. No, it's just about the new Faro destination is the idea that the microservices that have the Faro SDK in them currently, because they're currently using the Grafana Cloud Faro endpoint, is the idea that this would now go to the local Kubernetes service of a Alloy Faro pod, or
Yeah,
okay.
yeah, that's a great question. So the topology of deploying the front-end observability feature to work with Grafana Cloud front-end observability, definitely the ability for just adding the SDK into the web app and sending the data directly to Grafana Cloud, that still will work, and you can totally continue to do that. If there are environments or requirements where you don't want to have an external connection out to Grafana Cloud directly, this feature would allow you to send them into the cluster first and then send them out to Grafana Cloud. Notably, the change for this topology, deploying with the Kubernetes Monitoring Helm chart, likely would mean that you would need to deploy an Alloy, or maybe it's Alloy metrics, Alloy receiver, something like that, or it's a new Alloy that you would deploy. That would need to be deployed with maybe some sort of ingress or something like that, because it would be connections initiated by the user's browser that would then need to come into Alloy before being captured there and then delivered out to Faro. So
that would seem to make it a more complex deployment than what we're currently using.
You're not wrong. There are, but everyone's got different requirements and different deployment types, and so it's potentially less so. It could be used for people who aren't using publicly accessible web apps, but maybe intranet apps or something like that, where the idea of bringing all of the data together into a common source before exfiltrating the data out to Grafana Cloud is more of a requirement. So it is, regardless, it's been something that people have been asking for a long time. And previously, the way that we've been handling it is, here's a chunk of extra config code that you can add to your deployment. And so it's always been possible, but this way makes it a lot cleaner.
Yeah, Rob brings up a good point. It's probably more for the open source community than people using Grafana Cloud.
Sure.
Okay, it makes sense. Thanks.
Yeah. No, good questions. I did want to highlight, so we talked a little bit about this before the recording started, but in the application observability feature, we have the interval processor. Interval processor is still within Alloy. I think it's under the experimental release level or something like that. we found that there's a bug there that will try to send traces to that, and the traces aren't compatible. I'm aware of that, and so I'm going to try to get a patch out to fix that real soon. So if you're using the interval processor, be aware that we'll in the 3.3.2 release, likely coming out later today, we'll have a fix for that. Other questions? I do know that there's been a bunch of questions on the Kubernetes channel on the public Slack. I am planning on getting through those ones. But if you have a question directly related to that, yeah, please let me know.
Hey Pete, I had a question, if that's all right.
Yeah.
Firstly, thanks for running these. These are great. I was wondering about the recent change to move the pod names out of the Loki labels and into the structured metadata sort of segment.
Yeah.
It would be super useful to be able to, rather than have to take over the list that you have in the values chart of all the pod labels, all the log labels, sorry, that we send to Loki, to be able to like append an additional list if we do want to include, rather than having to take ownership over the whole list, which might, update in the future. And I guess for any place where you have a predefined list of stuff that somebody might want to add something to it without having to, maintain the whole original list as well. It'll just be super convenient kind of in those cases to be able to just append it to some other list and then merge them together in Helm rather than taking control.
Totally agree. Helm and arrays are always a little bit tricky. It's honestly it's YAML and Kubernetes and all these sorts of things, but Helm definitely is the way that a lot of people see this problem. For those who don't have the context, in the pod logs feature, we have two lists. We have a list of labels. It's called labels to keep. Basically, we turn a ton of things into labels, and then we have this labels to keep list that filters them down. And then we have a second list of things to take from labels and turn them into structured metadata. The thing with Helm is that if you want to change an array, you have to redefine the entire array, because Helm doesn't know, are you trying to add one element or are you trying to set the existing contents of the array? And so Helm just says, oh, you're probably trying to set a whole new array, which means, like Martin said, that when you want to just change something, you have to take ownership of the entire contents of the array. And one of the big downsides as a maintainer of this chart is that if I add an element to that array, anyone who's redefined it doesn't get it, because they will have to append that to the list that they're maintaining. And I don't like that idea. I would want the users of this chart to trust that, updates that we bring are in the user's best interest. And so they shouldn't have to keep aware of these sorts of things and maintain that. So yes, I totally agree with that. If I'm going to go back one tab to the upcoming features, this log gathering and reorganization feature will contain a fix for that. What I'm trying to avoid doing is introducing breaking changes for people who are using the pod logs feature today and have things set up the way that they like it. So this feature, the log gathering and reorganization feature, will likely soft deprecate the pod logs feature, but then introduce new features within the Helm chart to do pod log gathering based on volumes, pod log gathering based on API, other methods that we don't even have today. So like gathering via a Loki receiver, so you can actually push logs into Alloy, or gathering with special log setups. Like if you're on an OpenShift environment, you can configure the OpenShift cluster itself to just automatically send log data. And so you don't need to do anything else other than that. So there's some really cool things to do that. With those features, I definitely am going to take a strong pass through it with the usability framework in mind. One of the reasons why the pod logs feature and those two lists kind of became tricky to manage is that that one feature, the pod logs feature, is trying to do three different styles at once. It's gathering via the volumes, which gathers logs in the Loki style. You can turn on the file log gather method, which does the same thing, but then it's an OTLP format, or you can do the k8s API based method. And so that labels to keep list was trying to be tolerant of all sorts of different gather methods. With the new features that are coming up for this log gathering, it really should be a lot clearer, and definitely will be avoiding lists of that nature. So yeah, thanks for highlighting that. I've definitely felt the pain of a bunch of people asking about that and having to tell them, no, you have to give us the entire list back again. And that's not a great experience. So that's definitely high on the list of things to improve.
Amazing, thank you. I had one more question, if that's okay.
Yeah.
Oh, brilliant. I was looking at the documentations, and there was a page around setting the persistent storage in the write-ahead log kind of stuff.
Yeah.
And I was wondering, with the move to the alloy operator, is there an option to have like a single setting where you say true, enable persistence in alloy, and then that would permeate down to all the different types of alloys that you deploy? Because I guess the example in the documentation has you having to redefine the persistent volume effectively for each type of alloy.
Yes.
Individually.
That is a great question, and that is something that we didn't talk about in, I think, last time's office hours. But another usability change that came up, and maybe I just missed this from the slides or something like that, but inside of the main values file, there's a new section called collector common. And then inside of collector common alloy, you can put anything, and that will apply to all alloy instances that get created. Asterisk on that, there's a bug that I need to fix right now. It does for all of the kind of the main alloy instances, even though I'm lying and saying that it works for tail sampling and service graph. I think that it doesn't work for the tail sampling alloys. So that will come again. That's that's a bug fix that will come in 3.3.2. But if you put, if you have, well, let's just look at, alloy receiver, often you set, or was something that you wouldn't want to set on all of them, like a pod annotation, pod labels, the storage, like you mentioned. If you want to just turn on live debugging for all of them or set the log level within this collector common, you can do that and it will apply to all of the alloy instances. I like showing the screen and showing the examples here so you can actually see what I'm talking about. So inside of, I think, the private image registry, this one has an example of using that. So rather than setting, all of these, individual services need to be directly told to use a private image registry. But down here, I'm not doing it for alloy metrics or alloy receiver because I'm doing it for collector common. So that means that all of the alloy instances that are deployed with this are going to pick up this data here for the image registry stuff. So this is one example of using it rather than having to define it, 1, 2, sometimes 5 different times. You can just deploy it once and it will apply to all of your alloy instances.
But nice. I guess though, in the case of the persistent storage, where I think some of the examples have like variations for each type of alloy, whatever deployed.
Yeah, so the collector storage here.
Or maybe it's the same across all of them.
They're roughly different because alloy metrics uses some storage for its write-ahead log. Alloy logs is using it for log positions. The difference between these two top sections here is just the name of the storage mount. So that's fine. We can name that differently. The part down here, this will be a little bit different. But anything that's different, you could put into the individual alloy section. And then anything that's common, but again, it'd have to be common across all of the alloy instances.
Yeah.
You could put into the collector common object.
Cool. Awesome. Thank you. Thank you.
Great questions. All right, I see more here. Are there specific reasons why operator hooks are not inheriting the operator tolerations? No, we can add that. It makes sense to a degree. I mean, it needs to run the Helm hooks that we've added in 3.3. They aren't running the same code, or obviously not the same code, but they don't need to be running in the same namespace or the same node as the Alloy operator itself. But I can understand that, you might want to run it on this, you're going to be running Alloy operator. I think maybe something that would just help this is just to be able to set the tolerations fields for those hooks. So that's that's an improvement that I can make. Second question is, can we also define tolerations as well for all of the collectors globally? Yes. The collector common applies anything that you can set into the Alloy sections, anything that you can deploy or you can set into an Alloy instance itself, you can put into that collector common. So that would include tolerations. So this is going to be, I'm really excited for that feature. It's going to be huge for things like setting environment variables, which are common across a lot of different Alloy instances, the image registries, like I showed, tolerations, labels, annotations, all that sort of stuff. Also highlighting how it's nice to be able to set things by object and not by array, because then I'm not having to redefine the array every single time, but defining the object itself. You can put anything that's common inside of collector common, and then anything specific inside of that one Alloy instance. Hit that button again. Good questions. Any other questions?
I have one more question, Pete.
Right.
Okay. I'm just curious. With the move again to the Alloy operator, are you thinking about moving any more of the Helm chart to be kind of wholly CRD based rather than, I guess, generating lots of config maps and then passing that to the Alloy instances? Do you see yourself kind of moving it in that direction, or are you happy kind of where it is?
I'd say that's a good question. What I have in mind, especially long term, when I look at like 4.0 or even beyond, I don't have any new CRDs planned. So I don't have anything in the works that adds wholly new functionality to the way that we're deploying things. One thing that you call out config maps. The Kubernetes Monitoring Helm chart specifically creates a distinct config map for the Alloy instances next to the actual Alloy CR custom resource that gets deployed. And that's intentional for a couple reasons. But mainly today, the biggest benefits that I see with that is that if you redeploy the Helm chart and all you're doing is you're updating the config, then you don't need the Alloy operator to reconcile that. We can just update the config directly. That also helps with a little bit of the, it minimizes the churn of an Alloy instance itself. It also keeps config inside of a config and not in larger and larger Alloy custom resource definitions, or not definitions, but the custom resource instances. We don't need to embed the config into there. Where I do see potential benefit and things that we may invest more and more time into in the future with regards to operators is utilizing more of what the operator gives us for more dynamic deployments. So in 3.2 and 3.3, 3.0 and 3.1, I think, the ability to deploy tail sampling and service graph metrics, those required additional Alloy instances, but we're not calling them out. We're using the operator to deploy these Alloy instances to really deploy a pretty complex topology without making it feel like you're having to manage out this large topology. Where I could see, and this maybe tips a little bit into what I have planned for 4.0, and I'm not really ready to fully commit to it, but I'll tell you kind of where I'm thinking about this. The idea with 4.0 is that we can do for the Alloy instances what we did for destinations in 2.0, where there are less hard-coded instances of Alloy in the Helm chart. There's not going to be Alloy metrics, Alloy logs, all these things, but you'll be able to give us the list or a map of Alloy instances, and based on what you're wanting to do, we can deploy that. One of the things, if I can go even further with this is totally speculative. This is not me saying this is how we're going to do it, but could we have a thing in which all you tell us is this is the feature, this is the data that we want to gather infrastructure metrics about these things, we want to have application ports opened, and then you just deploy the Alloy footprint that makes the most sense, right? Could we make it such that we can just say, we know, Grafana Labs, the central maintainers of the Alloy project, know the best practices for deploying to gather all of this data, and we just deploy an optimal topology out of the gate based on what sort of data that you're trying to get. This is, again, it's like way off in the future kind of idea, but it's one of those things that I think about when we think, what can we do with the Alloy operator beyond just deploying static instances? Can we actually make it more reactive, more proactive with making sure that things are set up in the most optimal way?
Nice, thank you. Yeah, really interesting.
But to more directly answer your first question, yeah, we don't have any plans to add new custom resource definitions. I specifically made the Alloy custom resource definition very broad. I mean, if you look at it, it just is like spec and open close brace. But I made that because I wanted to minimize, churn and updates of that CRD directly. So because I know as operators of clusters and operators and runners of the Helm chart, CRD changes can get hairy. So I'm trying to make sure that that shouldn't have to happen anytime soon.
Awesome, cool.
Good questions. Excellent questions. Any others? All right, great. But again, if you do think of more questions, or if you've got something that you just want to chat about, talk about, you can always find us on the Kubernetes channel on the Grafana public Slack, grafana.slack.com. I'm in the Kubernetes channel a lot. I've got a little bit of backlog of questions there to catch up on, but I will be working through that today. Otherwise, if you have issues or you have feature requests, you can also find us on the GitHub page, Grafana/k8s-monitoring-helm. This project is hugely motivated and built based on community feedback. And we want to make sure that whatever we make is something that is helping your jobs go easier and it helps you be more effective. So, the feedback is super important to us. And the contributions, oh my gosh, again, 3.3, some major community-driven contributions. It really means a lot, and I was really excited to see all of those come in. So if you want to help contribute and make the project better, we love getting those PRs. I would be happy, more than happy to work through some of the process of getting any of the changes or the automated unit tests and things like that working. So please reach out. Excuse me. Thank you so much for joining. I hope you have a great rest of your day and a great weekend. Take care, everybody.